In number 1, we want to find the end behavior of and horizontal asymptotes of this rational function. So the end behavior depends on the term with the highest exponent, that's called the highest order term in the numerator, and the highest order term, that's the term with the highest exponent in the denominator. All right, so we say as x goes to infinity, that's on the right, we look at minus 3x to the 7th over 2x to the 6th, reduce it, and we have minus 3x over 2. So we just have to see where this tends to. So x is going to infinity. Because of this negative, this expression is going to negative infinity. So as x goes to infinity, y goes to negative infinity. That means on the right, x going to infinity, that's on the right side of the graph. The graph goes down. All right, so down on the right. And as x goes to negative infinity, that's on the left, minus 3x over 2. Okay, now this is going to negative infinity, and we have a negative in front. It's going to go to positive infinity. That means up on the left. So that's the end behavior. Now, there are no horizontal asymptotes. The horizontal asymptotes only occur if we have numbers here other than infinity and minus infinity, some finite numbers. All right, so we'd say no horizontal asymptotes. Number 2, again, we're looking at the end behavior, so we're going to take highest order term divided by highest order term, and we'll say as x goes to infinity, that's on the right, minus 10 x to the 6 over 2x to the 6. Okay, if we reduce this, we get minus 5. So we'll just say that this y tends to minus 5. All right, and on the left as well, as x goes to minus infinity. Again, this expression, which goes to wherever y goes to, so we can say y goes to minus 5. So we do have, these are not infinity, so we have a horizontal asymptote at y equal minus 5. Okay, once again, end behavior and horizontal asymptote. So as x goes to infinity, we're looking at 3x squared divided by 7x to the 5th, and we're going to see where that goes. 2. Let's reduce this, and we have 3 over 7x cubed. Now, the denominator is going to infinity, so the quotient is going to 0. And we have the same thing happening as x goes to minus infinity. So we do have a horizontal asymptote at y equals 0. Okay. In number 4, we want to find x-intercepts and vertical asymptotes of this rational function. So we first factor the numerator and denominator. So here we have x minus 3x minus 7. And here we have x plus 5, x minus 5. And the x-intercepts come from the zeros of the numerator and the vertical asymptotes from the zeros of the denominator. So we have 2 vertical asymptotes. All right, x equal minus 5 and x equal 5. Those are vertical asymptotes. And here we have two x-intercepts. x equals 3, x equals 7. Those are x-intercepts. In number 5, we're finding the y-intercept. So to find the y-intercept, set x equal to 0 in this expression. So we have y is equal to, this is 0, this is 0. So we're just left with 8 in the numerator. In the denominator, x squared is 0, so we're left with minus 4. So that's the y-intercept. Y is equal to minus 2. That is the point 0, comma, minus 2 is on the graph. In number 6, we're doing a plus-minus analysis. So on the number line, we're going to place the zeros of the numerator and the denominator. All right, this denominator factors into x plus 7, x minus 7. So the zeros are from the numerator minus 5 and 2, and from the denominator minus 7 and 7. So let's start with minus 7. The zeros of the denominator will represent with an open circle. That's where the vertical asymptotes are. And so starting from the left, we have minus 7, and then we have minus 5. That's coming from the numerator, so I'll give that a closed circle. And then we have 2 also from the numerator. And then we have 7 coming from the denominator, so I'll give that an open circle, because that's where a vertical asymptote is. All right, now we just want to see if the expression is positive or negative in these intervals. Starting to the right of 7, let's say if we was to substitute in an 8, for example, into here, everything would be positive. 8 plus 5, 8 minus 2, 8 plus 7, 8 minus 7, everything is positive. So positive in this interval. And now we're looking between 2 and 7. Let me mention that minus 5, this factor, x plus 5, which gave us the intercept minus 5, has an exponent 2. So we're expecting, let me just put a star here, we're expecting the sign not to change on the right and the left. So basically, if this starts at plus, we're expecting a pattern of plus, minus, plus, plus, and then minus. In other words, it alternates except for here. So plus, minus, that's alternating, plus, but now it doesn't alternate, another plus, and now it continues alternating. Now it's minus. That's what we're expecting, but we'll just verify that. Let's say we put a 3 in. Okay, then here we have, well, this is squared, it's always positive. I'm not even going to bother with this. Let's go to here. 3 minus 2 positive, 3 plus 7 positive, 3 minus 7 negative. That's 1 negative. So negative here. Over here, let's say we put in a 0. Then this is negative and positive, negative. 2 negatives, so that's positive. Now let's say we put in a minus 6. So here we have a negative, here we have positive, here we have negative. 2 negatives, so that's positive. And let's say we put in minus 8. So this is negative, negative, negative. All 3 negatives, and 3 negatives is negative. So that's our plus-minus analysis. All right, now we're going to do a graph. All right, let's first get as much information as we can. So from the numerator, we get x-intercept 3, and from the denominator we get a vertical asymptote minus 4. Let's do the y-intercept. Set x equal to 0, and we have here minus 3 over 4. All right, and now end behavior. As x goes to infinity, x over x, that's the highest term over the highest term, equals 1. So it's just going to stay, it's going to tend towards 1 and go to 1. And as x goes to minus infinity, the same thing. So we can say we have a horizontal asymptote at x equal 1. Okay, let's put in this information. Let's start putting in this information on the graph. X-intercept 3, a solid circle, vertical asymptote -4, a dotted line at -4. If you want, you can also put an open circle here. Okay, let's also put in this horizontal asymptote at, sorry, this should be y equal 1. Horizontal asymptote at y equal 1. Here we go. That means the graph is going to flatten out. All right, now let's do our plus-minus analysis right underneath. The intervals are determined by the zeros of the numerator 3 and the vertical asymptote -4. So here's one interval, here's another one, and here's one more, just 3 intervals. All right, and the pattern is this. To the right of 3, everything is positive. In between, we have negative and positive. Let's also put in this y-intercept. I'll put it over here, -3/4. All right, so let's start. Here the graph is above the x-axis, and it is leveling off it here at 1. So we're going to connect this arrow with this intercept. Now the graph is going below. It's getting negative. So let's go below the x-axis and connect with the y-intercept, -3/4. All right, here's the vertical asymptote, and the graph is negative, so it's going to go down. So just continue and connect these pieces. All right, now the graph is positive, so here along this vertical asymptote, the graph must go up, and just connect it to this horizontal arrow where it levels off to y equal 1. And that's our graph. Okay, let's look at number 8. Let's just factor the denominator, x plus 7, x minus 7. All right, so there we have x-intercept 3 and y and the vertical asymptote -7, 7. All right, y-intercept y equal -3 over -49, or 3 over 49. All right, now let's do end behavior. When x goes to infinity, x over x squared, that's equal to 1 over x, goes to 0, and on the other side as well. All right, so that's a horizontal asymptote. Y equals 0. All right, let's fill in. All right, let's fill in the x-intercept 3, vertical asymptote 7, and -7. I'll put an open circle there. Y-intercept 3 over 49 is just a little bit above 0. Okay, horizontal asymptote here. Maybe I'll just at the x-axis. So this is horizontal asymptote, so I'll put a dotted line on top of it. Okay, So the graph is going to level off either this way or this way, and on the other side, this way or this way. Now let's do a plus minus analysis. Okay, we don't have anything squared here, so we should have an alternating pattern. Here are the intervals. On the right, it starts off being positive. If we substitute an 8, everything is positive. So I'm just going to do the alternating pattern since we don't have anything squared. None of these, let me put parentheses here. None of these parentheses are squared or raised to an even power. So we do have this alternating pattern. All right, here we have positive, so the graph goes up to the right of this asymptote, and I'm going to just connect it with this arrow here. On the other side, negative, so the graph is going down. Okay. Over here we have positive, the graph is going up, and negative, the graph is going down on this side of the asymptote. So let's start connecting. Let's say here this arrow has to go through this intercept and through this y-intercept and connect with this arrow. So you can see what it does. It's going to go something like this and connect with that arrow. And here these two arrows will connect. And that's the graph. It's a familiar type of graph. We've seen ones like this before. Okay, let's look at number 9. X-intercept 2. Vertical asymptotes -1, -5. Y-intercept. Let's put x equals 0, and here we'll have a -2 squared, 1, 5, and so that will be 4/5 for the y-intercept. And now the end behavior. As x goes to infinity, well, what quotient do we have here? This x minus 2 squared has a first term of x squared. Here we have x, and here we have x, so again that's x squared. So the end behavior levels off at y equal 1, and as x goes to minus infinity, it'll be exactly the same. Horizontal at y equal 1. All right, let's start filling in. So we're going to fill in 2, that's the x-intercept, and intercepts, and vertical asymptotes -1, right here. And -5, right here. Now we have horizontal asymptote at 1, so let's put that in. Okay, so we're going to have some leveling off. All right, now at the bottom of the graph, we'll do our plus minus analysis. This is a 2 over here. Okay, here's an interval, here's an interval, here's an interval, and here's an interval. It starts off being positive. We can see that if we substitute in 3, for example, everything is positive. So it starts off being positive. You see, this 2 has multiplicity 2, so it's not going to change to the right and left of 2. So this is going to be another positive. You can see that by just substituting in 0, for example. This is always positive, and this will be positive. All right, let's substitute in, let's say, a -2, something in between here. Let's say -2. And this is always positive, and here we'll have negative positive, so it'll be negative. And if we substitute in, let's say, -6, This is always positive. Here we'll have negative, negative, and that'll be positive. All right. Okay, so let's fill in our asymptotes. Let's see. I want to fill in this y-intercept 4/5. That's about here. That's our y-intercept. All right, let's fill in the asymptotes. Positive here, so I'm going to put an arrow going up. On this side, negative, I'll put an arrow going down. This side's negative, so down. And this side's positive, so put an arrow going up. Okay. All right, now let's remember that to the right and left of 2, the graph is positive. So when we connect with this x-intercept, it doesn't cross. It just, because since we have positive, positive, it stays above the x-axis. So let's connect this arrow. Don't have it go through 2, but have it just touch it 2. You see it stays plus plus, the graph stays above. It just touches the x-axis. Have it go through this intercept and continue up. So that's that piece of the graph. Now this piece, all right, we have this arrow going down and this arrow going down, and we have to connect them. All right, so we're just going to do that. Let's have it go up. It doesn't go touch the x-axis because we don't have another x-intercept, so it's just going to go up and down over here. And on this side, we'll just connect these 2 arrows.